Thank you so much for your time today. I'm delighted now to welcome on stage our very own Chief Revolutionary Officer, Senior Vice President of Engineering, and Chief Technology Officer, that's a lot of job titles, Ravi Mayuram. Welcome, Ravi.
Good morning, everybody. Thanks for making it at 9 a.m. I know it's difficult for me. Saw a lot of familiar faces here, faces I've seen since 2013. So welcome back. We must be doing something right. So you're here. A lot of new faces. Welcome to the show. And a lot of you couldn't make it in person here. I know you're already environmentally conscious, so you didn't want to do the carbon footprint thing by flying over. But this is the engagement economy. We'll come right to you. So thank you all for being here, first and foremost. For me, it's very satisfying to see this grow. My esteemed colleague from marketing waxed eloquent about a revolution, and some of you are wondering, is this something that is marketing? Let me assure you, there is a revolution going on. And let me also assure you, our marketing department did not start it. In fact, there is a term for this. It's called the Fourth Industrial Revolution. Human societies evolve over periods that we call them ages. It was the Stone Age, it was the Iron Age, the Bronze Age, and finally the Industrial Age. And in this Industrial Age, we have had many waves of evolution. The first industrial revolution was steam and water powered. And this is where the raw material could be shipped to where your manufacturing base was, and you can ship it back to where the consumers were. So that mobility is what triggered the first industrial revolution. Second was based on electricity and mass production. This is at best characterized by the moving assembly line that Henry Ford created, and that created the internal combustion engine, and that was the second phase of industrial revolution. And the third is driven by electronics. We all know that, and that's also the information age beginning. The fourth one is very different, the one that is beginning now. And this is kind of following the same pattern as before, but this one is very different. This is the first time we are going to see what people term as cyber and cyber-physical systems. This is when multiple disciplines are going to fold together to create something new, something that societies haven't seen so far, stuff like artificial intelligence, autonomous vehicles, genome editing, cryptocurrencies, the kind of stuff that is going to modernize the society. This is a process of creative destructions that societies go through, where an underlying piece of technology revolutionizes and then modernizes the society. So if you ask, what is the fourth industrial revolution's underlying that resource? It's data. In fact, the pattern that we're seeing is the same that we saw in the previous industrial revolution, which is actually more than just data. It's about the ubiquitous availability of data, which means the ability to move data seamlessly. Just like the way the steam engines, it's not like humans did not know about steam or iron or any of that stuff. Those have existed for a while. But the fact that we were able to put together all of that technology we knew into a form which was able for us to mobilize both people and resources is what created that set of revolution. Similar one, when we start to mobilize the data all the way from the cloud to the edge, and apply it to various disciplines, this is going to completely change how our society is going to evolve next. So you might be wondering, we know all this stuff. All this stuff has existed. So why didn't this start to happen before? What is limiting us? It is actually that mobility of the data. It's the fact that so far the data has existed in silos, and the fact that it doesn't flow fluidly between systems, from all the way from the server to the edge, or between various systems that are sitting. you sometimes do not know, the left doesn't know what the right hand has. That situation emerges. And that is what is changing with the new set of technologies that we have there. So the limitation is because even though we have had infrastructure, we haven't had the evolution in the software tier, especially the database tier, to allow you to be able to move this data in a fluid form, because they were all sitting in monolithic databases. And that understanding of how data should be, because we have been used to it for the last 40-odd years, is what is limiting us. And there are a lot of myths that are sitting underneath as to how databases should be or how data should be stored and moved that we need to bust, that we need to understand better if you're going to make progress in this one. So let's talk about a few myths that we all are familiar with and bust some of those. First one, cloud is easy, because everybody understands that we need to move the data to the cloud in order for it to be available more easily to everybody. And all you have to do is take that enterprise stack that you have there and move it to the cloud. Job done, right? That's exactly how many of the companies do it now. Absolutely wrong. The only reason you need to go to the cloud from a database perspective is actually elasticity. It's the elasticity that the cloud computing allows that you need to take advantage of. Without that, you're not achieving much by moving the workload and the databases that you have on-prem to the cloud. Now, elasticity is a capacity that existing traditional relational database systems do not leverage well. They are considered to be not horizontally scaling systems. They are vertically scaling systems. So if you move them to the cloud, you're not gaining much by that. So you need a modern database which scales horizontally as well as vertically, if it can, and be able to give you that ability to take advantage of the elasticity that the cloud provides. So it's about system or a database system that can actually scale horizontally and allow you to cost-effectively deploy based on your computational needs. So you need a modern database that scales horizontally and allows you to deploy at your choice, cloud native, and be able to extend it all the way from the cloud to the edge. This is something traditional systems do not allow you to do. So fantastic, you do that thing. Or the second option that people actually go for is to say that, some of these cloud providers give me a database as a service, let me go sort of use that. Now you abdicated your own responsibility by giving it to someone else to manage your data. So if they shut down that service for whatever reason, your business is also shut because they control the data. So last 15 years in the enterprise software evolution, one thing that we have learned is not to be in monolithic systems. Vendor lock-in is something people did not want. That's why the entire open source movement came about, where people can have control over their stack. By putting it all on the cloud and giving the vendor the full control, there is no way a business can basically survive when their most critical piece of data is in someone else's control. So the best way to do this is to generally deploy a database system which is natively built for the cloud and is also cloud agnostic. So that way you can instantaneously have multiple deployments where you can have active, and move it from one cloud to another cloud, or extend it from the cloud to your on-prem if there are security concerns about some data which you don't want to keep in the public cloud. So a hybrid deployment where you can have public clouds or multiple public clouds and a private cloud, and at the same time allow you to seamlessly extend that to the edge as well. And it'll be fantastic if you do that all in a database platform which is also open source. So that would be a better strategy in terms of how you want to approach the cloud, as opposed to the classic way of just doing a cut and paste of enterprise stack and putting it on the cloud. So that is the first myth I wanted to bust, is about elasticity and how we want to basically take advantage of that in the modern database platforms. The second is downtime is a reality. Let's accept that. Let's manage to that And how do we do that? We have people working in 8x3 shifts, and they are poring over many monitors and knock centers and making sure that the application is always up. The 5 nines is guaranteed by human diligence, human intervention, and that's how we are managing it for now. That is not going to scale for too long. What you need are databases, and databases are typically very notorious, that you need to actually manage them a lot more intrusively than even other systems. So what you need are modern databases, which will basically go from being just automatic to autonomous, where they will fix themselves for all kinds of scenarios. Databases that are built to handle failures. That's what it comes down to. Hardware failure, no problem. Another node in your cluster will pick up the workload. A software problem in the OS tier or any tier underneath the database, no problem. Take that node out, patch it, bring it back in. It'll rejoin the cluster and take care of your operations. A database problem, no issue. In the cluster, you can run it on what is called as a mixed mode, where if you have a 50-node cluster, and you can take one node at a time out, upgrade it from previous version to the next, while the rest of them are running in the previous version, and you can still have your 5 nines availability, even if there is a database software tier problem. On top of that, if there's an application tier problem, let's say it's a schema extension scenario that you run into, no problem. The application will still run while you have multiple sort of schema versions available simultaneously to you. So that's from the standpoint of the application stack. Now let's take the situation that the network fails, the rack fails, or the availability zone fails, or the entire cloud fails. No problem. You can set up your replication, your XDCRs, and your clusters, and you can move the data to the other one. If all of this stuff is working, yet the nearest cell tower to you fails, still the application should be working in your mobile phones. And that is done by syncing the data to your local phone. The data is available, so the application is always on, irrespective of anything else that's happening in the surrounding environments. So a database or a database platform that is actually built for failure is what you need. The traditional systems are not, or if you're trying to set them up for these things, they are humongous in terms of both cost and expertise that will require to set those things up. So these modern database platforms are autonomous, or getting towards autonomous more and more. They're automated much better, and they give you the always-on experience that you're looking for. The last one, this is something that I experience when I meet more and more developers. Many of them would tell me, I'm a back-end developer. I don't really care. My data doesn't really meet the customer, so this engagement type of a database is not of much value to me. Now, that's the biggest myth, because this entire digital transformation is about bringing the back office directly to the consumer in a personalized manner. So anybody who's thinking that they're working on back-end systems which doesn't impact the customer, may tell you, please find the next project, because you're not very relevant to your business. So you need to figure out those systems which are actually sort of gotten either so ossified that they are way in the back and they're not relevant. Those are in a maintenance mode. What you need to get to are those systems which are actually getting exposed more and more to the front end. If you're making a travel reservation, you're looking at the inventory of the airline. When you're engaging with your healthcare provider, you're looking at the back-end records of the healthcare provider. Or any shopping that you do, you're looking at the inventory and the catalog. These are all back-end systems directly brought to the consumer. You did not have this visibility before. Who had that visibility? There was an intermediary. Anybody with the name of an agent or a broker had access to all this information, but they are getting disintermediated, and you have direct access to all this data. So it's that movement of taking the back-end systems and moving it to the consumers. That's what this digital transformation is all about. But these back-end systems were built on traditional databases, and a lot of money was invested in them. because they are really mission critical. And earlier you heard Peter talk about United. Some of the stuff that they have in the backend, many systems running on mainframes and other relational systems, deep investments in those platforms and technologies, but inefficiencies all over the place. If an aircraft or a route was getting disrupted, which crew to bring is a humongous problem for them. Even though they had all the information, they were not seamlessly coming together in one platform for them to realize which is the nearest crew, which is the nearest pilot who can come and help just because some other schedule has gotten disrupted. So there's a lot of inefficiencies in terms of how they handle that, and they spend a lot of money. They actually assume that about 10-15% of their entire route is disrupted at any given point and is planned for, and there's a lot of money spent in managing that. By bringing these systems together, they use Couchbase as the platform to bring it together. You're able to basically now realize those economic value by having information, like I was saying earlier, left hand doesn't know what right hand is doing. That happens in many systems because information and data is not flowing seamlessly. So we talked about a few myths. One was about elasticity. The other one was in terms of failures, how they have to be built for failures and autonomous availability, autonomously fix themselves for better availability. And last was this flexibility that is required in a platform so the data is available and seamlessly moves for the engagement to happen. What this requires is basically a new data platform that is imagined for the newer realities. Now, memory is way cheaper than what it used to be. Networks are way faster. The applications that we are developing are very different from what it used to be 40-odd years ago when the relational systems and other databases were conceived and built. What we need for the modern economy, for the next industrial revolution, are systems which are extremely flexible, where data is fluid and is movable and is manipulatable, and systems can talk to each other much more. Data can be flowing between systems as well as allow you to program to them easily, something that is very, very easy to program, which has got the power and the flexibility to program, and yet at the same time give you the kind of performance at scale that previous systems could not give you, because now you have millions of users using the system as opposed to in the olden days when you would have tens of thousands of users maximum, or enterprise with 100,000 users must be using those systems. Now it's direct to the consumer, so millions of users, hundreds of millions of users with millions of concurrencies, what we're looking for in these systems. So what is the kind of data platform that you're looking for over there? Is a platform that is generally built on certain foundational principles. One of memory first and network-centric architecture. One that basically moves data and manages the data underneath the covers without you having to intervene in managing that. On top of that, you basically have multiple data access patterns available to you, be it key value access pattern or the query, the nickel way of doing things, or we are introducing today is the launch of our 5.0. The Couchbase 5.0 is released as of today. With that, we are introducing full text search. This is a great capability where you can actually find more than just data. You can find information along with data with stuff like fuzzy logic matching and stemming for words. So it's information retrieval coming together with data retrieval in this platform today. We're also working on analytics, which gives you ability to find information and beyond information insight. So in one platform, you can find data, information, and insight all the way from the cloud to the edge. That's where we have the mobile capability, which can actually move the data from your data centers all the way to the edge on devices. And surround this with a great programming model. This is where we have a SQL or NoSQL and our other capabilities in the stack, as you can see, with a security and big data integration. These are must for this platform to be fluidly working with others. So this data platform gives you the ability to now develop with ease and deploy at any scale. Reflecting back on where our industry is, where Couchbase is, and even me personally, I find that we are in a very incredible position where we are participating and even enabling this digital revolution. This is a time where innovators and creative thinkers are basically called upon to shape and reshape existing industries and at the same time forge new industries. I hope we have inspired this morning in some small measure to start your own revolution. Together, let's build those systems which will reshape existing industries. Together, let's conceive and build those new systems which will modernize our society. There is great responsibility in this for all of us because we have great power that is given to us with this amount of data that we have in our hands. So together, let's build a better future. Thank you.